Okay, right now in question C, they say that in the diagram below, E, F, G, and D lie on the circle with center C, right? So C is the center. Then they say that lines ED and line GD are extended to H and J respectively. HB and JB are drawn with HB with angle HBJ equals to 100 degrees, and then we are also given that angle FCE is equals to 50 degrees and FGC is equals to 35 degrees. And then the question asks us to prove that DHBJ is a cyclic chord. Now to prove that DHBH, we're gonna have to either prove it by opposite angles equals to 180 degrees, or we can either use exterior angle of a cyclic chord equals to interior opposite angle. So we can either prove ne so this is what I'm gonna show you. So we can either prove that that angle over there is equals to this angle, right? Or we can prove that this angle, when you add it to that angle, it should give you 180 degrees. So it's up to you in which way you can try and prove this. So basically what we need in this question, we're gonna have to find D1 in all of this, so we can try finding a way to either finding angle D3 or angle D1. Immediately we find angle D1, it's going to be easier for us to find angle D3 or angle D4, because to find angle D4 we're going to just say angles on a straight line, and to find angle D3 we just basically going to say vertically opposite angles. All right, now let's do that. Now to find angle D1, right? Now to find this angle, sorry, now to find this angle, I'm gonna have to find first this whole entire angle there. All right, so for me to find D1, I'm gonna have to try and first find angle F1 plus F2, and then from there onwards everything should be much easier, because immediately I find F1 angle F1 plus F2 combined, I'm gonna use the reason of opposite angles of a cyclic chord to try and find angle D1. Now to do that, let's see, so let me just quickly rub that out. Now to do that, I want you to understand this. We are told that C is the center of the circle. This means that FC is gonna be a radius, and it's gonna be equals to CG, because CG is also gonna be a radius, and that line over there as well is gonna be equal because that is also a radius. So FC, CG, and CE, they are both radius, so you should just put lines over there to show them that they are all equals. Now I'm gonna have to use basically two triangles to try finding angle F2 and angle F1. Now the first one that I'm gonna work with, I'm gonna first work in triangle CEF. Alright, so I'm gonna first work in triangle CEF. Now in triangle CEF, I have that angle FCE, right? So angle FCE, it's actually 50 degrees. Now to find the other angles, remember angle F2 is going to be equals to angle E1, right? Now the reason for that is gonna be FC equals to CF. So let me just say CF according to the triangle. So I'm gonna say that CF is equals to CE, right? And then I'm gonna just put a reason by saying isosceles triangle. Isosceles triangle. All right, now to calculate those angles over there, Now I can just say that angle F2 basically it's gonna be 2 times F2, because remember FC, because in the way that you could have wrote it down, you could have said that F2 plus F2. Okay, let me show you what I mean basically, so that you don't get confused. So you're gonna say that angle, so you're gonna say that angle F2, right, plus angle E1 is going to be 180 degrees minus angle FCE, right? And the reason for that is going to be interior angles of a triangle, right? But remember that F2 and F2 and angle E1, they are basically the same thing. So I can just, if you add them up, they're going to basically give you 2F2, right? And this means that you're going to say 180. Now remember, FCE, we are given that is minus 50 degrees. And you're going to say 2F angle F2. So if you say 180 minus 50 degrees, you're going to get 130 degrees. So that's going to be 130 degrees. If you divide both sides by 2, angle F2, it's basically going to be equals to, so 180 divided by, it's going to be 65 degrees. All right, now using a different color. So now we have just found that, so that is 65 degrees, right? Now we're going to try finding angle F1. Now to find angle F1, I'm going to work in triangle CFG, right? And then in triangle CFG, angle F1 is going to be equals to angle FGC. FGC, right? And the reason for that is going to be that CF is equals to C, it's going to be equals to CG, I mean to say, so it's going to be equals to CG. All right, my G, right? So CF is going to be equals to CG, and also the reason they are still the same is I saw C-less triangle. All right, now remember F1 is equals to FCG. That means that actually F1 is going to be 35 degrees. All right, and I'm going to change color one more time. So this means that now to find angle D1, remember angle D1, it's going to be D1 plus angle F1 plus angle F2, which is going to be equals to 180 degrees. And the reason for that is going to be opposite angles of a cyclic chord, right? Then I'm going to say D1 is basically going to be 180 degrees minus angle F1 plus F2 combined. All right, then to get my answer, it will be 180 minus 65 degrees minus 35 degrees, right? And then, so it's going to be 180 minus 65 minus 35, and it's going to give me 80 degrees. 80 degrees. So now I have just found that angle D1, right? So I have just found that angle D1 is actually 80 degrees. Now the way in which I'm gonna go about it, I'm gonna just go the way of an exterior angle. So now I'm gonna say that angle D4 is going to be equals to 180 degrees minus angle D1 1, and the reason for that is going to be angles on a straight line. Angles on a straight line. Then it's going to be 180 degrees minus 80 degrees. Then your answer that you get is going to be 100 degrees. Therefore, this means that angle B is equals to angle D4. Right, now we had to prove, and then we can now see that therefore DHBJ is a cyclic quadrilateral because interior angle because exterior angle is equal to interior opposite angle. Right. So, or another thing that you could have done differently, rather than going that way, you could have just said that D3. So you could have said that D3 equals to D1, and then you're gonna say vertically opposite angles. Meaning that D3 is going to be basically 80 degrees, right? Then you were going to say that therefore D3 plus HBJ, D3 plus HBJ, it was going to be equals to 80 degrees plus 100 degrees, which was going to give you 180 degrees. And then the reason that you were going to use was that DHBJ is a cyclic because opposite interior angles is equals to 180 degrees. All right, and then yeah, basically that's how you could have proven that, and proven that DHBJ is a cyclic chord. All right.